am I audible at the back? All good? Awesome. So yeah, let's combine all the things today. So combine is something which Apple launched recently in WW this year. So just a quick check. How many of you have RX background? Any sort of reactive background? Quite a lot. And how many of you have tried combine, in side projects or just to see what's going on? Okay, very few, which is good. Because this talk is very introductory. It will take you from the very beginning what combine is, how it goes with reactive ideology, and we'll see some examples as well at the end. So a bit about me. So I'm Ritesh, and I work as an engineer at Over, and that's my Twitter handle. You can find me. I mostly retweet stuff, very few original tweets, but about iOS and Swift. And then I write a bit on Medium as well. Currently, I'm migrating to my own website. It's taking a bit of time, and then you can find me on GitHub as well. I like to open source whatever things I feel like they're isolated components. And the nice thing that you'll see about all the open source projects I've done, they all have a reactive layer on top of that. And this made me curious about combine as well, how we can use from day one and stuff. Okay, let's combine, right? A bit of warning in the beginning. So we are in the beta phase right now, right? It's just few weeks that Apple launched this stuff. And every beta, 1, 2, and 3, and 4, there were significant changes in each of them. So some things which you see right now on screen in the next 20 minutes might not work tomorrow. It's a fair bit of warning. Because things are evolving very fast, but it's who cares, right? We still want to learn and grow. Okay, so combine. Combine is a declarative Swift API for processing values over time. Now there are a lot of cool keywords in this one line. It says declarative Swift API. It's declarative, which means that you can read what it's doing while reading the RX code. It hides the implementation for you, so you can just read casually as well. Then it's for processing values over time. That is, you have a source of a value that it emits over a piece of time, and you can listen to it. These values represent many kinds of asynchronous events. So these values need not be basic types, like string or integers. It could be real complex objects, it could be users, it could be a login thing, it could be anything. And it customizes handling of asynchronous events by combining event processing operators. So a lot of difficult words you can see already on the slide, right? But all of them they make a lot of sense once you understand what combine is. So in short, for now, let's see that it's a reactive framework by Apple, right? And at the end, we'll come back to it and why everything makes sense. And the history of combine, so it goes even before Swift was, being in development. This famous tweet by one of the Apple folks that combine is something which Apple was doing for quite a long time. So as I said, combine is a reactive framework by Apple. So let's try to understand what reactive framework or reactive programming basically means. Reactive framework or reactive programming is basically works on the observer pattern, right? So you have a publisher which gives you value over time, and then you have a subscriber at the end of a chain and that listens to the value, and then you can act on it. That's what it is. And the closest example that you can think of is NS notification, right? But reactive is a lot more than that. Then you must have used operations in your code base. NS operations, NS operations make your handling of asynchronous tasks very easy, right? You can actually have a lot of complicated multiple async tasks. You can combine them, add dependency, you can add them to queues. All that stuff is also possible by RX. And they have a bunch of simple but yet very powerful operators. They have things like merge, zip, debounce. These are basically strategies, you can say them, or helper functions, and they really make your coding way, way easier. So RX is basically a combination of all these things. You can combine the notification pattern, the operation, NS operation things, and on top of that, you have operators that you can use. And there are a bunch of open source projects that you can use right away. There's Reactive Swift and there's RX Swift. Both of them, they follow the same principle underneath, but they have two different implementations that you can see. So if you want to dive into reactive first and not combine, I recommend going, cloning the repo or start using them if you want to learn more. So now we know what RX is, but why do we need it? Already without RX, we can make apps, right? But so why RX? So handling one async task is okay, it's good enough. But handling multiple async tasks, you start feeling the heat of it, right? You have multiple callbacks, you have multiple delegates, you have multiple state management, things going everywhere in your app, right? So RX helps you manage them. It can make your multiple async tasks very easy. Better state management. With simple programming, with imperative programming, your state lies almost everywhere again, right? But with RX, your state actually flows through the stream. So, and by stream I mean, when you're a publisher and subscriber, you make a stream of values, right? You make a connection, you make a subscription, and the state always follow in that stream. It's never out of it. Loose coupling of components. So when you deal with RX, you kind of make small components in the app, like decoding or encoding, like filtering, all those things. And those components are mostly loosely coupled, right? And this fundamental of, or the idea of loosely coupling of components is something that you gain automatically with RX. And of course, a declarative. And once you get hang of reading RX code, it's way simpler reading it as compared to the imperative world. But yes, you have to start understanding as well. So what's the current state of Combine? We know it's a reactive framework, but what it is right now? That's exactly this. So all the reactive folks, are diving into Combine now, and forgetting about what reactive Swift or RX Swift was. It's a bit sad and exciting as well, but yeah, that's what it is today. But yeah, and by the way, this is not my picture. I took it from Twitter. That's the source. Okay, so we know that Combine is a reactive framework, so it must have some foundation. Let's see what it is. Publisher is again, one of the core foundation of Combine. We'll see what it is. Subscriber is the second one, and operators that I already talked about is the third one. These three, they make the foundation of Combine, and once you get hang of these three, I think you can start playing with it pretty easily. So let's see what a publisher is. Okay, so publisher is something which emits sequence of values over time. In simple terms, right now I'm giving a talk, so right now I'm saying a bunch of words. I'm not sure if I'm making sense or not, but you are listening to it. So I'm a publisher right now. I'm saying a bunch of words over a value of time. So you can imagine me as a publisher right now. It delivers to a one or more subscriber. Now, in this room, I don't have only one person, right? I have multiple of them. So I can deliver this talk to all of you at the same time, and that's what a publisher is also capable of doing it. So you all are subscribers right now in a way. And from the type perspective, it's a protocol which Apple made, and it has two generic types, output and error. And then any publisher, that is, any stream can complete via finish, or it can finish via error. So let's say after 25 minutes I'll be done. That will be a completion, everything went well and I'm done. And failure is like my laptop doesn't work, or for some reason I'm not able to give this talk. That will be a failure. I'm ending this subscription or this, this thing pretty soon. And this is what it looks code-wise. So as I said, it's a publisher. It's a protocol which has two types, and it has this important function called receive. So whenever, like for example, if in this room, if I'm the only one talking, it doesn't make sense, right? It has to. I need an audience to talk to about. So when you attach a subscriber to a publisher, that's what then the thing starts happening in the reactive world. And with Apple, you get some free publishers out of the box. So basically, you might argue that, okay, I have a protocol, so what's next? Do I implement this protocol? Yes, you can, but you get free publishers, which Apple have already made for you. What are they? You have notification publishers that you can use. You can use URL session. If you want to make an API call, you have data publishers that you can use straight away. You have Just, you have Future. They are like baked-in publishers that you can start using right now without implementing the protocol. And then we have more subject things going on. So these are all publishers that you can use straight away, and they all serve one purpose, which we'll see later. Okay, so we know what a publisher is, right? So you can imagine me as a publisher right now, and so let's talk about subscriber. So you are a subscriber right now. You are listening to my talk, so basically you are receiving values, and all of you can, all of you can handle it according to you, the way you want. So basically, receive values from publisher. Generally, subscriber are at the end of a chain. By chain, I mean that so let's say if someone is publishing a value, and then you have some middle person like modifying the value. So at the end, you will have a subscriber. So those people are like listen to this stream. And by type, it's a protocol again, which has two generic types, input and error. So when you have a stream, when you have a connection, I mentioned that a publisher can cancel, like a publisher can stop the stream by canceling, by completing it by failure. Similarly, a subscriber can also end the connection, right? And you do it by canceling it. For example, you don't like my talk, you can go out right now. So that's like you canceling the subscription in a way. And you have some big subscribers already. You have like sync, assign any subscriber. You can use them right now straight away. You don't have to implement the protocol. And yeah, that's what it looks like internally by Apple. It has two generic types. It has three functions. The first one is receive subscription. That's get invoked whenever you attach a subscriber to a publisher, right? So when you make, okay, I have a publisher, a subscriber, let's connect them. The moment you connect them, you get a subscription, and that's when the data flow starts happening. The second one is receive input. That's how you get data in a stream. And the last one is completion. So you can complete things as well, either by finish or you can say by error. Now, a publisher and subscriber, they need to go hand in hand as well. Like you can't, it doesn't make any sense to use them separately. So this is the key function which you can use, subscribe. So every publisher will have a function .subscribe, and that's where you pass in your subscriber, and that's how the connection happens. There are a bunch of baked-in subscribers for you, like assign. So let's take this code one by one. So the first line, I have a publisher, which gives me values as strings. So imagine you are doing a search, right, and you have a keyword, and you're typing something. That's a query publisher for you. It's giving streams or strings. Then I make a subscriber in the next line. So I can use subscribers. Subscribers is the namespace that Apple has chosen. It's an enum, empty enum, and you can do .assign. So assign lies inside subscriber, and then you can pass the object. Now when you type something, you want to show immediately to the user, and that's where label is for. So you can pass a label object and attach a key path. And key path is you can say the consumer of that, right? So you want to attach your string to the label via text property. So you have publisher, you have subscriber. What next? As you can see, on the third line, we call that subscribe. And that's where the magic happens. That's how you link them together. And now you can, as you type, you will see the values in your label as well. In the middle, I have used two map functions. They are called operators. So when you receive something, you can modify them. Now map is pretty familiar to us now because we have been using map in, let's say, when you have collection or we have sequence in Swift. So you can imagine combine or any reactive thing is pretty much similar to what sequence is. So if you see a sequence API or the collection API, you will have API like map, filter, reduce, combine. All those API you can directly assume to work on publisher as well. And that's what the ideology is. They have actually made sure that all the APIs which were on the sequence or the collection actually works exactly on the reactor side as well. And then yes, you can cancel the subscription as well, like as I mentioned. Now, if you feel that there was too much going on with assign, you have to make your own object called assign, and then you had to attach to it, you can not do that as well. Sometimes you have a publisher for you, and you can call this nice function called .assign. An assign function is a function which Apple has already given to us. It's part of the publisher protocol, and you can just pass your object and pass your key path, and it will work out of the box for you. So that's like a compact version of using assign. So you can use two ways. And cancelable, right? That's a new word for us. So in Combine or in RX world, when you write something like publisher.map.assign, ultimately you get back a cancelable object, and by cancelable I mean that it's a subscription which you can cancel, right? And that's how, and you have to hold the reference of it. Once you have the reference of it, you can cancel things whenever you feel like. And Apple has this protocol called cancelable and a corresponding object called anyCancelable. And anyCancelable has this benefit of denating when your parent object gets reallocated. So it's important that you use anyCancelable. Just like assign, we have a new object called sync, and again you can make a sync using the same thing, subscribe.sync. The interesting piece is that it takes a closure, right? Which means that it's like a regular callback that you get when you do something, and inside the closure you can do whatever you want, and at the end you get a new subscriber as well. And I think the rest of the code is pretty much same, right? In the last case you had assign object, in this case you have sync object, and the flow is still same. You do a bunch of operation, and then you subscribe to that subscriber, and similarly you can cancel as well. So all these subscribers like sync or assign, they are cancelable, right? That's like an inheritance system. And again, if you don't want to use sync object, you can use the shorter version. Again, every publisher has this function called .sync that you can simply directly use to start receiving values, and you can do whatever you want in the callback. Okay, now we saw what publisher is and we saw what a subscriber is. We know how you can cancel as well, right? And you know how to hook them up now. We know a bunch of things. How about we talk about a bit of threading, like how do we handle threads in Combine? So we have this two nice function called subscribe on and receive on. What do they mean? Right. Let's take a look at this code. So I made a background queue at the top, and then I have a publisher. Then I'm doing a map, which is like I'm converting every string to a string searching for. Then I've called subscribe on a background queue, right? Subscribe on means that whatever your publisher was, or whatever your publisher was sending or performing the operation, do that piece in that particular thread. So in this case, let's say if I was decoding a very big object just above my subscribe on, this particular function will make that operation happen on the background queue. So that's like a pattern that you have to understand with Combine, that you don't apply threading inside the operation, you're applying threading while you are on the chain of events, right? So never put your threading inside the piece of code that you're writing. You can always apply threading while you are consuming it in a way. So subscribe on affects your upstream. What's an upstream? Upstream are publishers, something which is coming from top of something we are getting from a source, we call them upstream, and then you always affect your upstream using subscribe on. So if you can affect your upstream with threading, with receive on, you can manipulate how you want to receive events. For example, you are decoding an object in background thread. Now you want to assign that object to a label or an image view or something, your UI view. You can't do that in background. You will receive a warning. You have to do it on a main thread. And that's how you can do with receive on. So you call a receive on a main thread, and automatically whatever you got from the background thread will happen on the main thread now, right? And that's how you manage threading in Combine or in RX. And it's pretty straightforward, and it works really, really well. Though a word of caution, right now with beta 4, subscribe on doesn't work as it is documented by Apple, and it's kind of known a fact within the community. So if you go back and try this, it won't work right now, but receive on works as expected. So let's hope that in beta 5 or next release, it works as well, subscribe on. So subscribe on, let's just to summarize, receive on affects your downstream, that is your receivers, the subscribers. Subscribe on affects your upstream, that is your publishers. And in this example, what I did was, I asked my publisher to perform a background, and I asked my receiver to work on a main thread. Right? Okay, now what about the life cycle, Like what exactly happens when you attach a subscriber to a publisher, and what happens when you pass a value? That's a diagram I took straight away from the WWDC talk, which I highly recommend. There are like 2 talks that you have that you need to watch, and then there are a bunch of helper talks as well. But so what's happening right now here is that I have a publisher on the left side and a subscriber on the right side. Now, a publisher alone cannot send values. A subscriber needs to send a request first. So basically what it means is that the entire combine framework is centered around a subscriber, basically. So when you call .subscribe to a publisher, the publisher acknowledges that. And publisher sends you a subscription back to the subscriber. That, okay, I know you are there, and okay, I can send you the values. And then when the subscriber gets the feedback, it again tells the publisher that what sorts of values I need. And that's how you handle back pressure. Forget about back pressure right now. I just want to use this term so that you are aware of what that back pressure is something which Combine takes very seriously. Generally, the apps don't have the use case of back pressure, the iOS apps, but Combine is meant for multi-platform. So if you're building a server, you might want to use back pressure there, right? So requesting is a way of telling the system that, okay, please hold on, you're sending values too fast, slow down a bit, maybe. And then when this acknowledgement, which sounds like a TCP for a second, when this acknowledgement happens, you start receiving values now, right? And then you can complete this entire communication either via publisher, you can call .complete, or you can say .error, or you can finish this thing by a .cancel from subscription. So you can cancel this thing from both ways. Okay, now we know what a publishers and subscribers are. Operators are as important as these two things. So what are operators? They are like predefined functions, right? So when you saw .map or .filter or .anything, that's a function which Apple has given to you. And internally, they are actually types. So if you do .map, and if you go inside the documentation, it's actually a type called map. Similarly, FlatMap is also a type, filter is also a type, so every operator is actually a type behind the scenes. So that's why I've used the term publisher. So internally, they are publishers, but actually they are functions as well. And generally, you find operators between a publisher and subscriber, right? So if you look at this example, like the first one is a publisher, the last one is a subscriber, and in middle you have this map function. That's what an operator is. So operator affects or transforms your stream so that you get the actual value you want, right? Cool. So yeah, they transform the stream that you want. And the common example of operators are map, FlatMap, filter, merge, zip, debounce. They're like small packets of function that you can use very quickly on your stream as you go along. Okay, and this again I took from WWDC talk. So these are just a bunch of operators. There are a lot more than this actually, but don't get overwhelmed by these many operators. You won't have to use them at all of them. But you can see the bold ones, they are kind of pretty common in the RX or the combined world. But yeah, all of them are pretty important. So whenever you think of that, okay, you want to do something, first do a double check whether you have an operator or not. And the answer is that you might already have an operator for that, given by Apple. And if you see the map, FlatMap, contain, reduce, they also have a corresponding try as well. So error handling is kind of inbuilt in Combine as well. You can try things as well, and you can catch them. So all the native concepts that we are aware of in Swift, you can use them in Combine as well. And you can just assume that they work out of the box. So just try typing what you're thinking, and the chances are, the odds are they might already exist for you. So as you can see, all the APIs, they might sound familiar to coming from collections API as well, like reduce and collect and drop. So let's take a look at the map, right? So I have a query publisher. It's giving me a bunch of strings, and I apply .map, and I'm using .capitalize. And this is what I expect. So whenever I get a new string, it will capitalize the first letter of the word, right? So small s to a capital S, Swift to capital Swift, and so on. That's what this stream is doing. The next is filter, right? So what I'm doing right now is that don't give me empty strings, right? Because it doesn't make any sense for searching them. It doesn't make any sense to search an empty string to an API. So if I pass an empty string, nothing actually happens. The subscriber doesn't get notified because you filtered it out. Debounce. It's the most famous and most talked about, like I would say, operators, because it makes your searching life very easy for your backend developers. Because when you're searching, and let's say for every type, for every keyword or every letter, you're sending an API request, your server, will be angry, right? You don't want to do that. So what this Debounce does, that it waits for half a second between every 2 keystrokes, right? And if that, and let's say you're typing very fast and you wait for half a second, then it'll, get the latest value and pass it to you. So it's like slowing things down, Don't act on every input, but act when there's a difference of 0.5 seconds. That's what Debounce is. And we have a similar thing called throttling. Debounce gives you the last value, the last full value, and throttling gives you the first value. And it also has a bool which can make a throttling with the Debounce as well. So that's what it is. If you have 3 keystrokes, it will wait for half a second, and then it will give you the entire thing. FlatMap, it's again one of the interesting operators that you use. So let's say what's happening is that I'm typing something, and then I'm capitalizing it, and I'm also waiting it for half a second, and then I'm doing FlatMap another publisher. So basically what FlatMap does is that if you have a publisher, and then you combine with another publisher, you end up having a publisher of publisher. That's not what you want. Ultimately you want publisher of values. You never would want a publisher of a publisher. So a FlatMap flattens that out. So if you have a publisher coming in and you have a nested publisher, it will give you an ultimate publisher which won't be nested out, right? You can imagine FlatMap like if you have a 2D array in sequence or collection, it converts into a 1D array, right? So it flattens things out. Same way it's happening with stream. So if you have a nested stream, it will flatten things out for you. Merge, again, pretty common. So if you have a couple of streams coming for you, let's say if you are searching something, at the same time you want, let's say an auth token coming in, let's say if you same time you have like a login call or whatever, you can actually combine them together and you can merge them so that you don't receive again and again at the end. And then you have zip. Zip is again an operator which combines them together like a zip would do. If you are familiar with zipping, which I think all of us are as we are using Windows, so it combines all the things in one packet and gives you an output when everything is done. It's very useful when you want to hide loader when multiple API calls are done. Okay, do you have time for demo, or like how much time do I have? Okay, we have 2 minutes. Let me just quickly show you like a few things. Okay, let's combine things. Okay, basically I made this little app. It's an you can decrement stuff. So this is a button. These two are button, and you send signals for these 2 buttons, and this button is label, and that's act like a subscriber. So as you can see, if I tap plus, I'm sending values, and my label is listening to it, right? And same for my decrementer as well, right? So how's happening? So basically this is the code which makes it happen. You have a decrement publisher, you have an increment publisher, so you get the value, you convert into a string, you assign to your text, and that's how you do a bookkeeping of syllables, right? Forget about the last line, but yeah, this is what happening with this combined thing. And same for like increment as well. You map, you apply a bunch of operators, and finally you assign to your label, right? And yeah, this is what's happening with this thing. And let me quickly show you a demo filter thing. So what it'll do is that it won't accept negative values, and it won't accept more than 10. So if I do a minus, it won't work. I'm filtering out values. And if I go more than 10, again this thing it won't work. So as you can see, I'm sending values constantly, but my receiver is not listening because I have a filter. And same goes for the opposite side as well. Well, this project I'll open source it on GitHub, so you can check it out with ease. And as you can see, this is what's happening. I'm filtering out if it's more than 0, and again like less than 0, right? That's what is happening in the. So again, like it was as easy as adding a filter everything, right? You just modify your stream on the go, and that's what combine is all about, right? I have a bunch of other cool operators, but again, a lack of time, so you can just see them online. Okay, getting back to the slides. So what's next? There are a bunch of topics I couldn't talk about: subjects, memory management, error handling, debugging. A lot more to combine, but again, like we can chat about that later. Publishers, back pressure, multicast. These are a bunch of like advanced topics that again one can look into if required. Further reading, well, I have made a bunch of links for you guys. There are a bunch of online videos, Apple documentation, forums that are pretty useful, some open source projects, bunch of online links. So yeah, I'll put it online as well later. So yeah, thank you so much. If you have any question, I'll be outside.
Thank you, Ritesh. As said, you can meet Ritesh in the office hours room, which is the sponsor hall right across the main auditorium. If someone wants to go, now is the time. We will not let you in for the next talk, just saying, because it's like too disruptive for the next speaker.
Last one is a subscriber, and in middle you have this map function. That's what an operator is. So operator affects or transforms your stream so that you get the actual value you want, right? Cool. So yeah, they transform the stream that you want. And the common example operators are map, FlatMap, filter, merge, zip, debounce. They're like small packets of function that you can use very quickly on your stream as you go along. Okay, and this again I took from WWDC talk. So these are just a bunch of operators. There are a lot more than this actually, but don't get overwhelmed by these many operators. You won't have to use them at all of them. But you can see the bold ones, they are kind of pretty common in the RX or the combined world. But yeah, all of them are pretty important. So whenever you think of that, okay, you want to do something, first do a double check whether you have an operator or not. And the answer is that you might already have an operator for that, given by Apple. And if you see the map, FlatMap, contain, reduce, they also have a corresponding try as well. So error handling is kind of inbuilt in combine as well. You can try things as well, and you can catch them. So all the native concepts that we are aware of in Swift, you can use them in combine as well. And you can just assume that they work out of the box. So just try typing what you're thinking, and the chances are, the odds are they might already exist for you. So as you can see, all the APIs, they might sound familiar to coming from collections API as well, like reduce and collect and drop. So let's take a look at the map, right? So I have a query publisher. It's giving me a bunch of strings, and I apply .map, and I'm using .capitalize. And this is what I expect. So whenever I get a new string, it will capitalize the first letter of the word, right? So small s to a capital S, Swift to capital Swift, and so on. That's what this stream is doing. The next is filter, right? So what I'm doing right now is that don't give me empty strings, right? Because it doesn't make any sense for searching them. It doesn't make any sense to search an empty string to an API. So if I pass an empty string, nothing actually happens. The subscriber doesn't get notified because you filtered it out. Debounce is the most famous and most talked about, like I would say, operators, because it makes your searching life very easy for your backend developers. Because when you're searching, and let's say for every type, for every keyword or every letter, you're sending an API request, your server, will be angry, right? You don't want to do that. So what this debounce does, that it waits for half a second between every two keystrokes, right? And if that, and let's say you're typing very fast and you wait for half a second, then it will, get the latest value and pass it to you. So it's like slowing things down, Don't act on every input, but act when there's a difference of 0.5 seconds. That's what debounce is. And we have a similar thing called throttling. Debounce gives you the last value, the last full value, and throttling gives you the first value. And it also has a bool which can make a throttling with the debounce as well. So that's what it is. If you have 3 keystrokes, it will wait for half a second, and then it will give you the entire thing. FlatMap, it's again one of the interesting operators that you use. So let's say what's happening is that I'm typing something, and then I'm capitalizing it, and I'm also waiting it for half a second, and then I'm doing FlatMap another publisher. So basically what FlatMap does is that if you have a publisher, and then you combine with another publisher, you end up having a publisher of publisher. That's not what you want. Ultimately you want publisher of values. You never would want a publisher of a publisher. So a FlatMap flattens that out. So if you have a publisher coming in and you have a nested publisher, it will give you an ultimate publisher which won't be nested out, right? You can imagine FlatMap like if you have a 2D array in sequence or collection, it converts into a 1D array, right? So it flattens things out. Same way it's happening with stream. So if you have a nested stream, it will flatten things out for you. Merge, again, pretty common. So if you have a couple of streams coming for you, let's say if you are searching something, at the same time you want, let's say an auth token coming in, let's say if you same time you have like a login call or whatever, you can actually combine them together and you can merge them so that you don't receive again and again at the end. And then you have zip. Zip is again an operator which combines them together like a zip would do. If you are familiar with zipping, which I think all of us are as we are using Windows, so it combines all the things in one packet and gives you an output when everything is done. It's very useful when you want to hide loader when multiple API calls are done. Okay, do you have time for demo, or like how much time do I have? Okay, we have 2 minutes. Let me just quickly show you like a few things. Okay, let's combine things. Okay, basically I made this little app. It's an we can increment decrement stuff. So this is a button. These two are button, and you send signals for these two buttons, and this button is label, and that's act like a subscriber. So as you can see, if I tap plus, I'm sending values, and my label is listening to it, right? And same for my decrementer as well, right? So how's happening? So basically this is the code which makes it happen. You have a decrement publisher, you have an increment publisher, so you get the value, you convert into a string, you assign to your text, and that's how you do a bookkeeping of your cancellables, right? Forget about the last line, but yeah, this is what happening with this combined thing. And same for like increment as well. You map, you apply a bunch of operators, and finally you assign to your label, right? And yeah, this is what is happening with this thing. And let me quickly show you a demo filter thing. So what it will do is that it won't accept negative values and it won't accept more than 10. So if I do a minus, it won't work. I'm filtering out values. And if I go more than 10, again this thing it won't work. So as you can see, I'm sending values constantly, but my receiver is not listening because I have a filter. And same goes for the opposite side as well. Well, this project I'll open source it on GitHub, so you can check it out with ease. And as you can see, this is what's happening. I'm filtering out if it's more than 0, and again like less than 0, right? That's what is happening in the. So again, like it was as easy as adding a filter thing, right? You just modify your stream on the go, and that's what combine is all about, right? I have a bunch of other cool operators, but again, a lack of time, so you can just see them online. Okay, getting back to the slides. So what's next? There are a bunch of topics I couldn't talk about: subjects, memory management, error handling, debugging. A lot more to combine, but again, like we can chat about that later. Publishers, back pressure, multicast. These are a bunch of like advanced topics that again one can look into if required. Further reading, well, I have made a bunch of links for you guys. There are a bunch of online videos, Apple documentation, forums that are pretty useful, some open source projects, bunch of online links. So yeah, I'll put it online as well later. So yeah, thank you so much.